Challenge 10 Cafe, where we make everything science, technology, engineering, and mathematics easy to comprehend, assimilate, fun, and entertaining. According to our mission, we really want to make everything STEM fun, easy. So, for those who are in advanced stage, middle stage, and the basic stage, I like to handle some basic arithmetic aspects, and we should enhance, the fun in handling mathematics. When we get to the class of mathematics, we are introduced to numbers, and number is our main raw materials, our main raw material in STEM, and it's good that we know how to manipulate these numbers and some of their properties in handling them, so that we can, find it easy and playful when handling them. What I know about it is make it an obsession. Make handling numbers an obsession, and mathematics will become, just like playing game. Let's talk about numbers. Numbers, these are the things that we use to represent quantity, either physical or non-physical quantities. Representation of quantities or measurements. Some quantities are physical and some are not physical, they are felt. Like when you are talking about force, when you are talking about electric currents, all these things, we use numbers to represent them. Even the angles, directions, we use numbers to represent them. Everything, our currency, our money, we use numbers to represent them. And that is why it is good. We know about this. So many people know about it, a little bit about these numbers. But because there are so many aspects they don't know about, they tend to find some aspects difficult. Not really too difficult, but they are slow in, understanding some aspects of mathematics when we are handling them. Now, let's talk about natural numbers. We are talking about numbers generally. Now, this is a class of number, natural number. These are mainly positive numbers. Those are the ones that, yes, we know, that we measure, we handle. They are common numbers, everyday numbers that we are used to. We are used to this. These are common numbers that we are used to, mainly whole numbers. And it is a mixture or arrangement that involves 0 to 9. So, in this instance, you can have 0, okay, you can have 1 and 0, which is 10. You can have 9 and 1, which is 91. Etc. And with this, you just need to, when we start learning numbers, we start from 1, 2, 3, 9, 10, like that. So you can see it's a mixture of this. And what we know is that as we are moving from this, the numbers are increasing. The numbers are increasing. So you can represent this on straight line, which we refer to as number line. And how does that work? If this one starts from 0, you can have 1 here, 2 here, 3 here, and it goes like that. The main thing you know now is from this place to this place, we have 1 unit. From this place to this place, you have 2 units, 1 unit. From this place to this place, you have 1 unit. So it increases like that, continuously, like that. So that is the main thing you know about the natural numbers. And when we are talking about 0, it means that thing does not exist. When we are referring to natural number, it is not appearing. It does not have any relevance. That's what we mean by 0 in this under natural numbers. And under natural numbers, I told you that the number increases as we move from left to right. That's how we represent it. The number increases. So as it gets to a place, you have 10, 1 to 10. Then it increases again. You can come like this, it gets to 20. increases, it gets to 3 or 3 numbers. So you can see. So this gives us the idea of place value. Talk about place value. It means that when we have a mixture of number or arrangement of number, each number, what is its relevance in that arrangement? How big is that number in that arrangement? Let me tell you what I mean. When we are young, we are taught this thing. They will say 100, tens, and units. I said something the other time. We start with 0, 1, 2 to 9. In this place, under this place, the numbers can just be 1, 1, 1, 1. After it gets to 9, it now increases to 10. And 10 involves 2 numbers. So that is why we have it like this. So if I have a number here, 9, 6, 3. You can see. So if I have only 9, only one number, the only number before here, the only number, if I have a single number, it will be here. So when you have a single number, like 0 to 9, that is units. We call that one unit because it has one figure. We call it 1 unit. Now, let me now have another one here. Let's say I have 2 here. You can see the number has increased tremendously just by adding 2 to the front of the 4. So in this case, the place value of the 2 here is 10. It's 10. And if you look at the arrangement of number, we have 1, 10, 2, 11 to 20, 21 to 30. You can see, as it gets here, all of them here, they are in tens. You see, they are in tens. 2 tens, that is 2 times 10. 3 of tens, like that. But this place is still units. Because we form our figures by arrangement of different, let me see. We form the numbers by arrangement of different numerals. Let me put it that way. By arrangement of different numerals. And these are the numerals. These are the numerals. Please take note. So we are using them to represent the quantities. So when it is still small, that is, we have it as single, we call them units. But when we have it as double, we are going to have what we call tens. When we have them increase, we are going to have hundreds. Like this. So in this place, the place value, when you are talking of place value, for 6 now, is 10. For 3, it's 100. For 9, it's units. So this knowledge also makes us to know how to pronounce the number. How to pronounce the number. This is not the all or restriction of the place value for numbers. After this, we have units, tens, hundreds, we have thousands, we have 10,000, we have hundreds of thousands, and then we have millions. Continuously like that. We have billion, we have hundreds of millions, we have tens of millions, we have continuously like that. But under each place, you can only put one number each. And as it is being added, the number is increasing tremendously. So that is the little thing about place value. It's very easy. When you have 3 numbers, you can easily know where is the place value of 1. Like this one now. Like this one. Because I know the place value for this, I can pronounce this number in words. I can tell you, and the person I am telling the number can easily, get what I am saying. Let me tell you what this is. So like this one now. If I want to say, you can see this one is unit, this one is 10, this one is 100. If I want to pronounce this, I'll be able to say 300 and 6. This 6 here is in tens, so we call it 60. So this makes it in tens. 369. You can see 69. I know you are used to it, so just as a reminder or revision. Then we also have the lower place value, that is the tens, hundreds, thousands. You see, this is, I've told you, as it is increasing like this, it is being multiplied by 10, more and more. It is increasing tremendously. So when it is going like this, it is reducing. So what does that mean? It means that if I have this place, if I have these tens, hundreds, thousands, I'm going to have points here. to show me that it is dividing by 10 as it is going. So let's say I have 6, 4, 5. You can see. So most times we just say 0.645. You don't, we don't say it in hundreds, thousands, or tens much. But if it is just single, you can just say, what is the base value of this one? It is 6 tenths, 4 hundredths, and 5,000. So if you are being asked the base value for each of this, that's how you just say it. So the base value for this. Now, don't let us waste time much on this. Let's look into another aspect of our numbers. So before I go to the next one, I like to mention this again. I told you that when you have points here, and you have something like 645, note this is decimal points. And as the number is going towards this place, it is getting smaller. The place value is making it smaller and smaller. So this one, if I have it like this, 1, 1, 1, it means that this one is 10 times this. This one is 10 times this under our number. That's what it means. So as it is moving like this, everything is multiplied by 10. This one, like this one is 1 here. It means this is 10 times this. This one is 10 times this. If I have 1 again, please know what I am stressing this. I have 1, 1, 1 in this place. All of them are the same. So this one will be 10 times this, 10 times this. Look at this one too. 6, 6, 6. This one, the value of this one is 60. Let me see. The value of this one here is 6 hundredths, 6 thousandths, 6 tenths. You understand? So this one is 10 multiplied by this. This one is 10 multiplied by this. Let me show you what this is. This one here is 6 over 10. This one here is 6 over 100. And this one here is 6 over 1000. That is all. Very simple. So because they are combined together, so you can see this one is 6 times this, 10 times this one is 10 times this. That's what I've been trying to say. Now let's talk about integers. Now let's talk a bit about integers. When we were younger, they will tell us subtract 4 from 2. We will echo impossible. That was because we were very small then. I mean, maybe then you can call it nursery or crèche. But after some time we grew up, we realized that the use of a set of numbers called integers has made this operation possible. And what are the integers? We said that the numbers increases to the right. We have 0 here, 1, 2, 3, 4, 5, etc. So, to the left, which means you can have figures smaller than 0. Smaller than 0. It means that I can make this place minus 1, minus 2, minus 3, minus 4. I told you in the natural number sense. 0 means that thing does not exist. It's not appearing. It's not there. But in this instance, the 0 has value. The minus 1 has value. So this one that we used to refer to as impossible, it has now become possible with the help of integer. And this will be equal to, we have minus 4 here, plus 2. That's what it means. Minus 4 plus 2. And it will be equal to minus into 4 minus 2. And this is equal to minus into 2 because 2 is there. That is what it means. So when you subtract a bigger number from smaller number, it does not mean that thing cannot be done. It means that it will come towards this side, in the negative side. So that is why we have the number set we call integers. It has the positive and the negative. So you can see with this, we have mentioned slightly about decimal and then fraction, but we'll talk about those ones later on. Also, we have rational numbers and irrational numbers. Now let's talk about rational numbers and real numbers. You see, rational numbers, they are numbers that you can express as fraction completely. Let's look at some. Rational numbers can be expressed as fraction. E.g., you have half, 1 over 5, 0 0.5, 0 0.2, 0 0.3, etc. But irrational numbers, And if you want to write them in terms of decimal points, it will have so many strings of number that you cannot even, there can't be a concluding figure to say, okay, this is what it represents. So irrational numbers cannot be expressed as fraction or complete decimal form or be abbreviated in terms of fraction or decimal. E.g., if you have a number like root 2, root 3, you cannot express it because it will continuously have so many strings of numbers. So many of them are not even repeating themselves. And it makes it very difficult to say, okay, this is the real figure for this root 2. E.g., if you check root 2 now in your calculator, if you check root 2 in your calculator, you are going to have something like 1.4142. You have several strings of numbers. So at the end of the day, you cannot express root 2 as a over b. It's not possible. Because all of this, you cannot come and give it fixed value and say, okay, root 2 is equal to a over b. No. That is why those are the ones we call irrational numbers. And then the numbers we call real numbers. The union of rational and irrational numbers. Just like when we talk about integer. Integer includes the natural numbers and the negative numbers. So, real number consists of rational and irrational numbers. Even under this rational number, you can also have 2, 4, 3, any of them that can be expressed like this. But this one, even, I think 5. I think the number e, it will continue. You cannot express it as a fraction or pure decimal like that.